Welcome back. So let me continue from where I was. Okay. So we are looking at this firm problem. At the first stage, the firm needs to produce its production capacity using a production function that takes inputs of land, labor, capital, and all other primary factors. Okay? We assume that this production function is of constant returns to scale. Okay? In the second stage, the firm will produce the value added, and the value added, of course, will depend on the intermediate inputs as well. So what you see is this. If the firm J, wants to produce Yj units of output, it needs Yij units of good I. Okay? So there is here Aij is a real number. Okay? Here there is a technical relationship between intermediate inputs. Okay? Here we are looking at this from the viewpoint of firm J. Okay? So firm J has this production target, Yj. For this production target, there is a linear relationship between all the other intermediate goods. Okay? So if I want to produce, let's say, 100 burgers, I need 100 units of bread, for instance. Okay? If I want to produce 100 burgers, let's say I need 5 kilograms of onions. Okay? There's always a one-to-one linear relationship between these intermediate goods. Okay? Because each produced good, again, each produced good from 1 to n is in the meantime an intermediate input to other firms. Okay? So here, Aij are called technical coefficients. Okay? And of course, they create this technical or sometimes input-output coefficients. All right? And of course, they define this matrix, right? Input-output matrix. A11, A12, dot, 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 A1n, A21, A22, dot, 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 A2n, AN1, AN2, dot, 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 ANN. Right? And of course, AII or AJJ, more specifically, is what? For 1 unit of production, Yj also needs its own production as input. Okay? So if this is a agricultural product, let's say it's a crop, then to produce some of it, to produce some of this product, you need this production itself to use as seeds. Okay? So A here is called input-output matrix. Okay? So to produce then 1 unit of J, firm J needs Aij units of I. Okay? That's the idea. Then, as you realize, the production function become the Leontief production function. Okay? Because you have y1 a 1j, y2 a 2j, right? Is that correct? Sorry, y1j a 1j. Let me write it again. You have y1j a 1j, y2j a 2j dot dot dot, ynj a nj, okay? And here you have the value added. I'm going to explain what it is in a moment, okay? So the idea is that, okay, we need the burger house, right? Produced by this. Then so this is, again, produced by primary factors. Okay, then I have intermediate inputs. Then I have intermediate inputs. Okay, now they also produce for a given capacity. They must be consistent with this amount. Now look at this. This is a minimum function, right? This is a Leontief function. So remember what happens when you try to optimally choose the inputs in the Leontief function? Well, these must be all equal to yj, right? By definition. And then this must be, of course, consistent with the value-added production. So what is value-added? We have this relationship. Value-added is produced by the primary factors. Okay? Because your value added to this economy is originating from your production of the burger house. Right? Your value added, because these goods are already produced and you can use them only as intermediate inputs. Okay? What you can create as new depends on your newly produced stuff, and that stuff is the value added. Okay, the early production function that we defined for the production of goods. Now, what's the relationship here? The relationship is there. Let me just double check. So yes, so this value added must be equal to, again, this must be equal to yj, right? So this value added must be equal to vj times fj. Okay? Because this is equal to, once again, remember that yj is equal to, this is your production capacity, it is equal to this. Now yj, in the meantime, must be equal to value added j divided by vj. And you may ask, of course, what is vj? Vj is also a technical coefficient. Okay? So it is the technical. Understand how it works. So to produce 100 burgers, okay, to produce 100 burgers, you create this amount of value added. Okay, and that value added, of course, will depend on how much labor you are hiring, how much capital you are renting, how much land you have. All right. So again, this looks a bit complex, but it's actually not. If you think about it, first you need to produce your burger house, your firm, okay, using primary inputs. But those primary inputs now is the value added you create, right? Because the other stuff you use, the bread and the onions and the ketchup and mayonnaise, all these are already produced. So your value added to this economy is the burger house itself, it's the firm itself. Now that production relationship will be consistent with the Leontief production function. Why? Because to produce a particular amount of burgers, you need a particularly sized factory, okay? Because your production capacity, your value added, in other words, will depend on these factors. If you create a large burger house, you can produce large amounts of burgers. But also, for each burger, you need a particular amount of, so to produce a particular amount of burgers, you need a particularly sized burger house, you need a particular amount of bread, you need a particular amount of onions, you need a particular amount of ketchup. Okay? And those relationships will, of course, depend on, and those units will depend on these technical coefficients. All right? So do you have any questions about this? So this is a bit different from a typical firm problem that you've always studied. But this is, as you see, much more realistic, right? Because in the real life, if you look at firms, if you look at many different industries, you see something like this. First, there's this first stage production. You create your value added that creates a production capacity for your firm. And then using intermediate inputs for your production, you create your product. And these input-output relationships are represented by this Leontief production function, because it is necessary, right? You need a particular amount of onions, a particular amount of bread, and a particularly sized burger house to produce a particularly given target of burgers. Okay. So that's that. Now, of course, we want to understand how do we solve this problem, right? Because now we have production functions. We already done. So these are so we have production functions, okay, and we have factor prices and product prices. Now we can discuss how to solve the problem. Now, one thing you may imagine is the problem of cost minimization. Okay, so if you want to write the total cost of producing YJ units, how do you write that? Well, first of all, you're gonna pay for the primary factors, right? From K1 to K, you're gonna pay for what? You're gonna pay for your demand of what was the notation here? X. Okay, you're gonna have XKH, right? Sorry, XKJ. Obviously, this is firm. All right. So this is the part you pay for primary factors. In other words, this is the part where you pay for your value added. Okay. Plus, what do I have? plus I must have some further costs, right? What are these?
Intermediate goods.
Yes. How do I write that?
Price times.
So okay, there's price. Then for YJ production, remember for YJ, I am using YIJ units, right? Right? And there are how many of them? How many of them?
IJ, I guess.
Okay, so to produce YJ units, I need YIJ units of good I, right? And I pay the price PI, obviously, because this is the good I. And how many of them are there? There are N of them, right? Right? So this is the cost associated with intermediate inputs. Okay? Now realize one thing. If Yj is given, then this part is given, right? What does it mean? So if you imagine that you are the consultant for this burger house, so the entrepreneur knocks on your door, all right, and tells you, okay, I want to open this burger house, and I want to produce YJ units of burger per day. Okay. Then you, given the recipe, right, you create this calculation for the need of intermediate inputs. So, okay, if you want to produce 10,000 burgers per week, 10,000 burgers per week, then you need this amount of onions, this amount of bread, this amount of meat, this amount of ketchup. All right, YIJs. Then firm has no power to change this cost, right? Because to produce that particular amount of burgers, the entrepreneur must pay this amount. He cannot change that, right? This part cannot change. So then optimal production problem becomes a simple problem of cost minimization, right? Given a production target, what is the optimal mix of production inputs, right? Because this part doesn't change. This part doesn't change. So the only thing the firm can do is to solve this problem. Now, let me give you a very simple example. Suppose you have X1 here and X2 here, okay? So your value-added production is what? Is X1, X2, right? Little f. And then, of course, this is like V times big F. Very cool. Okay. Now, if this production function is well behaved, what do you know? Well, there will be iso product lines, right? These will be iso product lines, each associated with a particular level of production. Remember this? Then there is also this, right? There's also what is that? This line comes where? This is the cost, right? ISO cost. So there are ISO cost lines. So you have omega 1 x1 plus omega 2 x2, right? So for any given cost level, so this is like x2 equals c minus w1 x1 minus w2, right? So what does the firm do? Well, there is a typical production target, yj, okay? So this is yj, a typical production target. And this is again j and j. So for this production target, the value added production is this, right? So it is Vj times Yj. So let's say it is here. Okay, let's suppose this is that particular production target, Vaj. Okay? Then the firm finds the optimal mix where? In here. Right?
Yes.
So that's the same problem now. Right? Let me go to the previous page. Now that's the same problem. There's a production target. Since the production target is given, this part doesn't change. So firm can only adjust the technology, the input mix. Okay? So if we write this problem formally, minimize total cost you pay for primary factors, right? By choosing x1j, x2j, xkj, sorry, xkj, right? Subject to what? Subject to a production constraint. What is that production constraint? Well, it is very simple. It is this. Right? Now, in this problem, be careful, Yj is given. And also, omega k for each k are given. Okay? So if we write this for the previous example of two goods, we have minimize by choosing x1, x2, omega 1 x1 plus omega 2 x2, subject to you have, let's say, y equals x1 to the theta, x2 to the 1 minus theta. Okay, where theta is between 0 and 1. Okay, now this is the typical Cobb-Douglas problem that you always studied in your micro lectures. Okay, so depending on the production function, if production function is well behaved, well, if we, I mean, we already assume that it's constant scale. If you assume that, you know, since this is a production function, of course, production should increase in the inputs, right? So that would be much more sensible. Then you can solve this problem. And then find, after solving this problem, of course, you find x, k, j star, and that will be depending on what? That will be depending on the production prices, sorry, factor prices, and your production target. Right? Because if you want to produce more, you would hire more of these goods, more of these factors. Okay, if you want to produce more burgers per week, you need a larger burger house. You need more cooks, at least 2 managers, a larger land, and more waiters and waitresses. Okay? So again, if you want to produce more at the same factor prices, you're gonna hire more of these inputs. Okay? So that's that. But we also have, now let me go back to where I am. I was here, I guess. Yes. So once you find it, realize that you can write this function as xkj omega va j as well, right? Because there is a one-to-one relationship between yi and vaj. Again, don't forget yj is equal to value added j divided by vj, right? So if that's the case, your total cost will be written in this way. So your total cost, so this is the cost of firm J. Okay. Now it will be what? From K1 to K, omega K, X, K, J, omega, VA, J. Right? Now, here's an important result. Under constant returns to scale, we have this. So we can write this function in this way. So basically, we can separate this into that. So what is that? This result is very important. Okay. If the production function is constant returns to scale, then we can separate the total cost function into 2 components. This is the unit cost. Okay. So this is the unit cost. In other words, cost of producing, cost of producing 1 unit of value added. Okay. And this is how much you're going to produce. Okay. So this is an important separation result and requires that production function is constant returns to scale. Okay. And of course, we're not going to prove it. I mean, there's a proof, but we are not understanding that. I mean, we are not interested in that. Okay. Now, we're going to denote this as the price of value added. Okay. Price of value added. So that price of value added for J is then this. Okay. That will be very important when we try to define competitive equilibrium. All right. Now, of course, you must be very careful with one thing here. This is the price of value added if the firm behaves optimally, right? So firm here chooses optimal factor demands. Okay. Under this optimal choice, we can find this price of value added. All right. And as you see, the price of value added does not depend on the scale, right? And this is obvious because this is constant returns to scale. So the scale of production does not affect the price that the firm pays, right? Because again, it is constant inertial scale. But be careful, this is the optimal solution. So this result occurs, this is the price of value added, if the firm behaves optimally, and we can only write the cost, total cost in this way. So this is optimal cost, in other words. We can write total cost in this way only if we have constant inertial scale. All right. Now I can write total cost in a particularly interesting way, particularly useful way, right? Because remember, cost was this. Cost was total cost you pay for primary factors, okay, plus the total amount of payments you are making for intermediate inputs, okay? Now, what did I find? I find that in the optimum case, this could be written in this way. And this is written in this way, right? Now, also recall that this is also written in this way. Now, what happened here? I expressed the cost of firm J as a function of output only, right? Remember your micro lectures, you usually talk about cost function in this way, right? Right? As a function of production. Sometimes you do that, sometimes you do that, things like that, right? Now, this is exactly what it is, the cost function. And cost function appropriately defined as a function of output only. Why? Because to produce that output, we assume that firm will behave optimally in terms of input mix. Okay? In terms of primary factors, given a production target, the firm will choose optimal input mix, optimal factor demands. Okay? Now the problem becomes the choice of output target. The problem, the firm's problem becomes how much output to produce, right? Because I already created my burger house, I already created my factory, I have already hired my workers, my managers, my cooks, and my waitresses, and I already have vehicles and the buildings and all this stuff. Now the question is, to make profit, how much I should produce? Because I know I've already gathered around the optimal mix given the factor prices. Okay? Once again, if you compare this to the other problems that you faced in your other lectures, this is much more realistic compared to them. I mean, this is still very unrealistic on certain respects, but at least this looks more like the real world firm behavior, right? Because now I have the firm, and each period now I can ask myself, okay, what is my production target for this quarter? Now there's COVID. Now what is my production target under COVID-19? All right, things like that. So. Let me check where I am. Okay. Okay, now I can define average cost as well, right? So the total cost is this, price of value added for J, the technical coefficient Vj, okay, and the production target yj plus summation of from y to n pi aij yj. Okay, so that's the total cost. Then the average cost, the average cost is defined in this way, right? So I have PVAJ, VJ plus, careful here, each term has YJ here. So I have PI AIJ. Okay. Now realize one thing, in this model, average cost is equal to marginal cost, right? If this is the total cost function, it is linear in YJ, right? It is linear. So average cost and marginal cost are the same. Okay, and this is that function. So I can now define profit. Okay, profit will be what? PJ YJ minus total cost. So total cost could be now written as a CJ YJ. Okay, in other words, you can write this as PJ minus a CJ times YJ. Now, obviously, a firm like this will produce as long as price is larger than average cost, right? And okay, so again, we have less than a minute. Time is 10:35. Let's meet at 10:50. All right? 10:50.
Okay.
You hear me? 10:50.
Yes.
Yes.
All right, all right. Let's meet at 10:50.